Hello and welcome back to Mastering Data Visualization with D3.js. In today's video, the first of section 2, we're going to see about all the components needed to build up a plot that has the normal pieces we would think of with a good data visualization. In this section, we're going to see how to use scales to convert from data to screen coordinates, the different kinds of scales that D3 provides, how to annotate our axes, how to use color, and finally, how to design good, aesthetically pleasing plots that are also good at conveying the information we want to show. In today's video, we're going to take a look at scales. In this video, we're going to see how domains and ranges work, how to set up dynamic scales that automatically adjust for the data range we have, and finally, how to tweak the scales for certain kinds of specific use cases. Let's dive right in. So we'll begin by starting up a simple little web server and serving up a very simple JavaScript. In this script, you can see I've written just a single function here called random walk. It takes in a single argument, the number of points that it will use to generate an array containing that number of points. It will then populate that array using the math.random function. And then we've created this new object called a scale linear object. And we give it these two values, domain and range. Let's take a look now and see what this does. So if I call my function here and I give it, let's say, 100 points, you can see what I generate is that nice random walk that we saw in the last section. Now, we can actually do better than this. So we know, because of math.random giving us values between 0 and 1, that our maximum and minimum values here are going to be 0 and 1. But we can actually rewrite this to be a little more universal. Now you can see I've replaced these min and max function values of 0 and 1 with D3's min and max functions. And these behave very similarly to your math.max functions. So you can see D3.max takes in a list of elements and returns the maximum value, as does math.max once you've unpacked that list of items. So now if I call my random walk function, you can see it does exactly what we did before, except this time, rather than manually specifying the range of my data, I'm allowing my scale to automatically determine it for me. So when you're writing reusable plotting functions, using scales to automatically range your data into the pixel coordinates of the screen is very useful. Now, what happens if we don't necessarily want to cover the whole range of data? Let's say we only want to deal with half of this range. So say we might have a situation here where the upper half of these data values are not actually important to us. Perhaps it's beyond what we want to consider in this particular set of data we're looking at. Well, now, if I run my plotting script, you can see what happens is my data is, of course, cut off. I'm only looking at the upper half here. And you can see where this line crosses the screen. If I zoom in here, you can see it actually breaks the path. Now, this is fine for this particular application, but sometimes you want to maintain your continuous data. You want to make sure that this data doesn't actually become discontinuous. And for that, you can use the clamp method. If I call clamp true here, will happen if I rerun this plotting function, you'll see even though I've cut off my data, it actually maintains a continuous curve here. So clamp, what that does is it actually forces the data to always be between the maximum and minimum values of your domain. When it exceeds that domain, it simply substitutes in the maximum or the minimum value, whichever is the appropriate one.